Hi everyone. I will explain you why you can't use any equation of moments with an equation of force. So usually we do force on x, force on y, and a moment, but we can also do force on x and two moment and force on y and two moment. But we have to be careful with the point that we use, and I will explain you why. Okay. So today we will talk about the equation of moment that we can use. Okay. I pick an example to show you. So it's not a foolproof, but you will see what happens. And I hope that you remember why you need to not pick those 2 points parallel or perpendicular to force on x and force on y. So we have this beam that has a L shape. There's a pin connection at A and there's a normal connection at C. And we have forces on them. Okay, I will call that F1. And we have a force there, F2. Okay, those are known forces. That's why they are in blue. Remember, I always do my forces in blue when we know them. And this is the distance A, and this is A divided by 2. Okay, distance. And this is the distance B. Okay, it goes all to B. Just make it simple. And this is the distance B divided by 2. Just to make it easy. Which forces do we have? Which unknown do we have? I make them in red when we have the unknown. We have a force at AX and AY because it's a pin connection. I will make it down. You will see it will be down ups. And we have a normal force at C and C this way. Okay. This is our free body diagram. Remember, free body diagram is the key to solve your equation. No free body diagram or no correct diagram, no correct equations. So based on that, we have three unknown. Three unknown. We need three equations. Okay. The ID number one, the one that we all think about, is to do, because we have a pin connection at A, sum of the moment. Oops, it's not a E, it's a sum. Sum of the moment about A equals 0 plus force on X equals 0 plus force on Y equals 0. This one that works, okay? And let's see my about A. Here we go. And other option is to do one equation of the force equals 0 plus two equation of moment equals 0. But the question is which equation of moment? So let's try. Let's see what's happened when we do our equation of moment. Okay, I will write 5 equations and I will show you the combination of those. I will do first equation of force. If we do sum of the forces on x equals 0, what do we have? We have AX minus F2 equals 0. Okay, equation number 1. Equation number 2, let's do sum of the forces on y equals 0. What do we get? We get minus AY minus F1 and plus NC equals 0. Yes. Let's do now equation sum from the moment about A equals 0. Equation number 3. What do we get? We get, so positive direction is counterclockwise, so we have minus F1 times A divided by 2. This is the moment done by F1. F2 create a negative moment too, so minus F2 times B divided by 2. And NC create a positive moment, so plus NC times A equals 0. Equation number 3. Okay. Equation number 4. Let's do sum of the moment about B equals 0. Okay. Familiar there, so what do we have? We have AY that create a positive moment, so AY times A plus F1 times A divided by 2. And we have also F2 minus F2 times B divided by 2 equals 0. Equation number 4. Okay. Equation number 5. I know it's getting a bit smaller, but let me get my number 5 there. Sum of the moment about C equals 0. What do we have? Oh my god, everything is making a moment except NC for this one. So let's take the time to do that. We have AX creative and negative moment, so minus AX times the distance, vertical distance B, plus ay times a, that is positive, plus f1 times a divided by 2, and plus f2 times b divided by 2 equals 0. So now I have my 5 equation. Equation of force on x, equation of force on y. If we now use the moment about A and the moment about D together, okay? Let's look at what happens when we do the equation number 4 minus equation number 3, okay? So this one minus this one. What do we have? We have the A, Y, A, okay? The F1 times A divided by 2 minus F1, so plus F1 divided by A give us plus F1A. The minus F2B2 minus F2B2, that disappear. So, and we get just the minus NC times A equals 0. We can remove the A, okay? And we can switch the sign because you will see where I will go when we do minus AY minus F1 plus NC equals 0. This equation is equation number 2. So equation 4 minus 3 equal equation 2. What does that mean? It means if we do sum of the forces on y equals 0, we can't do moment about A plus moment about B. That doesn't work. No. Okay. So if we look at force on y and AAB, so the AB is perpendicular to force on y, that does not work. Okay. We cannot do 2 points that are perpendicular to the y-axis when we use the force on y. Now, let's look at my equation 4 and 5. Let me use another color. Let's do this. Maybe this one we will see better. So if we do these two, okay? Let me think. Equation B and C. So we need to do, if we do equation 5 minus equation 4, what do we get? Minus ax b, so that just gives us minus ax b. Aya minus aya, that's 0. F1 times a divided by 2 and F1 divided by 2, that's 0. And F2b divided by 2 plus F2b divided by 2, that gives us plus F2 times b equals 0. We can remove the b, and let's change the sign. We have ax minus F2 equals 0, which is our equation 1. So equation 5 minus equation 4 equal equation 1. So if we do sum of the forces on x equals 0, we cannot use the moment of B plus the moment of C. No. Okay? No. So if we do, because those equations are not independent, the combination of the mix of two equations give us another one. So this is not a 3 independent equation. If we put that in a matrix system, that will say the matrix is not inversible, right? So if we do the forces on x, oops, if we do the forces on x, so on that axis, we can't use 2 points that are perpendicular to x. Okay? So if we do sum of the forces on x, at the end, what we can do, let me write it on the below that. What we can do, we can do force on x plus moment about A plus moment about C, because A and C are not perpendicular to each other. We can do force on y, or you can do, if we want, okay, we can do force on x plus moment about A and plus moment about B. But we can't do B and C. We show that the equation were not independent. Okay, so this is for force on x. And now for the force on y that we showed before, we can do force on y plus moment about A plus moment about C, because the 2 points A and C are not either horizontal and vertical. And we can do force on y. So we prove that we can't do A and B, but we can do B and C, moment about B plus moment about C. So we can use 2 points that are parallel to the force, but not perpendicular to the force. Let me get that on just one big page. I know it's not always the same scale that I use, but let me get everything there. So this is the conclusion, and you get a little bit of an idea why we can't do that, because the equations are not independent. I hope that helps. Bye-bye.